Good day friends, my name is Dr. Shweta Goyal and now my another series in Norton problems is there. So please stay tuned till the last and you will find different types of question here, and after that you will be able to solve any numerical of based on Norton theorem. So this is our new problem and you have to calculate the Norton equivalent circuit with respect to this 10 ohm resistance. So load resistance is this AB terminal AB. Okay, now what you have to do, first Rn, you have to calculate Rn. So load open and source replaced. Okay, I am writing in short. So here two voltage source are there, so both will be the short circuit. If there is any current source, that will be open circuit. So this will be like this will be short circuit, this will be like this. AB terminal 6 ohm, 1 ohm, 2 ohm, 4 ohm. So this will be your circuit. Now you have to calculate the Rn. Rn will be, if you flow the current from here, you can find this will be the parallel and then this will be the parallel, and the both parallel combination will be there in series. So this will be like this, 2 parallel 4 plus 1 parallel 6. So 2 into 4 plus 2 plus 4 plus 1 into 6 upon 1 plus 6. If you solve this, that is 8 upon 6 plus 6 upon 7. Now if you solve this, you will get that is 5 upon 3 ampere. Now what you have to do, you have to calculate the IN. Okay, for IN, what you have to do, you have to replace the load with the short circuit terminal. So the circuit will be like this, like this, like this, like this. This will be short circuit now, and the voltage source will be there like this. That is 6 ohm, 2 ohm, 10 ohm, 10 volt, 4 ohm, 20 volt. This is your circuit. Let's suppose this is 20 volt, current is flowing from here. Okay, this is your ISC is flowing from here. So now you have to let's suppose we are applying here nodal analysis. Okay, nodal analysis will be applying here. Let's suppose 10 volt resistor is flowing, I1 is flowing here, then this is your terminal, AB's terminal is there, so we are writing here X terminal, and the current is flowing, that is I2, and then this is Y terminal, current is flowing through this, that is I4, and that current is flowing through this I3, and the current is flowing through here, that is I5. Okay, I5 equals to ISC. Now what you have to do, I1 in nodal analysis, I am writing here Kirchhoff current law by KCL. Nodal analysis you can do, that is at X node. At X node you can check I1 equal to I2 plus I3. Okay, I1 equal to I2 plus I3. Okay, now I1 is here, I is V upon R, that is 10 minus, because voltage will be there, 10 up minus Vx upon 6 or 60, that is 6 equal to I2 is Vx upon 1, what I have done, that is 1 ohm, plus I3 Vx minus Vy, Vx minus Vy upon resistance is 2 ohm. Okay, if you solve this, you will find or you can write 10 minus Vx 10 minus Vx, this will be go here, that is 6Vx plus 3Vx minus 3Vy. So if you solve this, that will be 10Vx, because 6 plus 3 9, 9 plus 1 10Vx minus 3Vy equal to 10. Okay, this is your equation 1. Now Vx will be, or we can write here, Vx equals to 10 plus 3Vy upon 10. You can write it. How, why we could do it? You can check here. This is short circuit. So Vy terminal is 20 volt. Okay, because this is short circuit. So you are directly you can write Vy equal to 20 volt. So you can write it here. 10 plus 3 into 20 upon 10. So if you solve this, you will find that is 7 volt. So Vx and Vy you have found. Vx is 20 volt and Vy you have, that is 20 volt. Now I3 will be, so I3 is Vx minus Vy upon 2. Vx you have, that is 7 minus 20 upon 2. That is minus 6.5 ampere. Okay. Now I4 was this. I4 equals to Vy upon 4. So I4 you got, that is Vy upon 4. Vy you have 20 upon 4, that is 5 ampere you got. So ISC will be I5 equal to, I5 is, you can find I5 is, I3 is going through this, I4 is going through this. So I3 minus I4. So that is I4 minus I3, that is I4 is 5 ampere minus I3, that is minus 6.5 ampere. So that is 6 plus 11, 11 plus 11.5 ampere you got, that is ISC. Now what you have to do, you have to make Norton circuit, that will be like this. Rn you have, RL you have, ISC you got, that is 11.5, 11.5. Rn you found, Rn, what you have found the Rn, that is 5 by 3. So you will write that is 5 by 3 ohm, and RL you had, that was 10 ohm. So if you find RL, IL will be by the current division rule, that is 11.5 into parallel, that is 5 by 3 upon 5 by 3 plus 10. If you solve this, you will find that is 1.63 ampere is your answer. So this is your question. Now you have to calculate the current or Norton equivalent circuit with respect to AB terminal. This is your circuit, 4 volt, 4.5 and 3 volt sources are there, 4 ohm, 5 ohm and 6 ohm resistance are there. So what you have to do, first load is 6 ohm resistance. So IN for Rn, open circuit load and replace source. Okay, this you have to do. So what will be the circuit? Circuit will be like this. This is your AB terminal, then this is your circuit, 4 ohm, 5 ohm. So AB terminal is there, so current will flowing from there, current will be divided into 2 parts here, so the both are in parallel. So 4 parallel 5, so that is 4 into 5 upon 4 plus 5, that is 20 upon 9. Okay, if you solve this, you will find that is 2.22 ohm. Okay, now for ISC what you have to do, the circuit is like this. 6 ohm resistance is fed by the 2 voltage source, so you can use superposition theorem, KCL, KVL, what you want. So if the load terminal will be short circuit, the circuit will be like this 3 volt, this 6 volt, 4.5 volt, this is your 4 ohm, 5 ohm and 6 volt resistance is your short circuit. So let's suppose I1 current is flowing through this, I2 current is flowing through this, and ISC current is flowing through this. So current will be flow like this. So ISC will be I1 plus I2. So I1 is 4.5 upon 4 because V upon R, plus here 3 upon 5. You have to solve this, that is 420, and this is 4.5 into 5 plus 3 into 4. Now 420 plus 12 plus, that is 22.5, that will be 34.5 upon 20. Okay, if you solve this, you can find that is around 1.72 ampere. Okay, 1.72 ampere you will get. Now what you have to do, you have ISC and you have RTH. So Norton circuit can be, in your textbook this is given, in many textbook this is given like you have to calculate the Norton of each, but I am giving you simple example here. So 1.72 you will find. The Norton equivalent resistance will be like this. You can do any question with your own. Okay, you can use superposition theorem, you can use this type of theorem, you can use any theorem, any Vx, Ix here, and you will find the value is same. So this is IN, RN was 2.22 ohm and RL was 6 ohm and IN is this. So you have to calculate IL equals to 1.72 total resistance into 2.22 upon 2.22 plus 6 ohm. So if you solve this, you will get 4.66 ampere, your answer. Now we will do one more example that will be very useful to you. Now this is your circuit and you have to find the load current in terminal AB. This is your Wheatstone bridge. Many students get scared from this type of question, so I am taking this type of question. So this is a unbalanced Wheatstone bridge. You can say 10, 30, 20, 40. If it was balanced, the all resistance will be same. So for RT, or we can say for RN, Norton resistance, the load resistance will be open and this will be the short circuit. Okay, so current will be like this, this, and this is your open circuit. This is your 10 ohm, 30 ohm, 20 ohm and 40 ohm. This will be your short circuit. So if you find this circuit is short circuit, you can find. देखिए, अगर आप इस टर्मिनल को ऐसे ना करके इधर लगा दे तो this terminal is short circuit. I have done this type of question in Thevenin also. So this will be, let's suppose this is your C and D terminal. So you can write it like this. C and D terminal is short circuit. So this will be like this. Okay, and this will be like this. This is 10 ohm, this is 30 ohm, this is 20 ohm, and this is your 40 ohm. This is your A, B terminal. So this is connected like this, A terminal, and this is connected like this, B terminal, and this is your C and D terminal is short circuit. The current will be flow like this. So you can find that this in series. If you flow the current from here, current will be flow like this and current will be flow like this. So this and this will be parallel, this and this will be parallel and this will be parallel. Both are parallel and both the combination are series. So you can write 10 parallel 30. Current will be flow like this, divide this, and then current will be divided like this. So 10 into 30 parallel plus 20 into 40 parallel. This combination and this combination are parallel. Sorry, this combination and this combination are parallel. So this will be, if you solve this, 10 into 30 upon 10 plus 30 plus 20 into 40 parallel upon 20 plus 40. If you solve this, you will get 23 ohm. This is your RL. Now, what you have to calculate? You have to calculate IN. For that, what you have to do, you have to short circuit the load resistance. So the circuit will be like this, and this will be short circuit, AB terminal short circuit. This is 10 ohm, 30 ohm, 20 ohm and 40 ohm. Then current this like this, 10 volt. Let's suppose I current is flowing through this, I1 is this and I2 is this. Current will be divided into two parts. Now current will be divided into two parts, that is IN is flowing through this, then I4 is flowing through this and I3 is flowing through this. Now what you have to do, you have to calculate the total current. Total current will be like this, I, total current I will be 10 volt resistance upon equivalent resistance. Equivalent resistance you have calculated, that is 20 upon 83, that is 40.48 ampere. Now if you do this I1 and I2 both are in parallel, you can draw this C and D. You can redraw this circuit. If you redraw, the calculation will be very easy to you. You can redraw like this, and this is short circuit. Okay, this is short circuit. This will be like this. This will be like this. Okay, because this is parallel, so you can make it like this. 10 volt. I current is flowing from here, that is calculated 0.48 ampere. I1 and I2 terminal C, and this is I3 and this is I4 terminal D. This is terminal D, and let's suppose no, this is terminal D, and let's suppose this is terminal E. Okay, I3 and I4, that is 20 and 40. This is 10 and 30. Now what you have to do, you have to calculate VCE and VED. Okay, so VCE equal to IR into RCE. That is I you have, that is 0.48 into RCE, 10 into 30 upon 10 plus 30, that is 0.48 into 7.5, that is 3.6 volt. Now VED, that is I, total current I, because these are in series, so I into RED. So I is 0.48 into RDE. If you calculate these, both are in parallel, so 13.33, that is 6.4 ampere you got. Sorry, volt, because this is voltage. So 6.4 volt you got. Now I1 if you calculate, that is VCE, because V upon, because both are parallel. If you calculated one, you can confound other also. So that will be upon 10, because this is 10 ohm. So that will be 0.36, because 3.6. Sorry, I can write here 3.6 upon 10. That is 0.36 ampere Similarly, I2 is VCE upon 10. So VC is 3.6 upon 10, 30. That is 30. You can find 0.12 ampere. Similarly, you will find I3. I3 will be I3 equals to, the voltage is VED upon the value is 20 ohm. VED was 6.4 upon 20 you will find, that is 0.32 ampere. Now I4 is VED upon 40. VED is 6.4 upon 40 you will find, that is 0.16 ampere. You got I1, I2, I3 and I4. Now I1, IN will be this and this, I1 minus I3. Okay, if you find this I2 minus I4 you can get. Okay, so we are taking like this. So IN will be I1 minus I3. So I1 is 0.36 minus I3 is 0.32. So you will get 0.04. Okay, you can also take I2 minus I4. So that will be 0.12 minus 0.16. Okay, so you will get 0.04 here. Answer. So I1, IN is this. So you can get IN. Norton equivalent circuit can be like this. IN, RL, and this. IN is 0.04. RL you got, that is 20.83, and RL was your 50 ohm. So if you calculate this, you will find the IL. If you IL you will find. So this is your Norton equivalent circuit. If you have any queries, student, you can comment me in the comment box. I will explain all your queries. So thank you, good day and take care. Please stay tuned for more and more videos. Please subscribe this channel for more videos. Thank you, good day and take care.